Hi everyone, it's Mr. Phillips. This is the first lesson of 5 looking at properties and changes of materials. Now this is normally a year 5 topic, but this is something you didn't cover in summer term because we were all off. So we're going to cover it really quickly at the beginning of year 6. So this is the very first lesson. For this lesson you probably need something to write on, maybe like a pad of paper and a pencil or a pen. This is our learning objective for today. By the end of the lesson, we want to be able to use knowledge of solids, liquids and gases to decide how mixtures might be separated, including through filtering, sieving and evaporating. Now I've included here some key vocabulary that you might use throughout this lesson, and later on when you're doing a bit of writing around this lesson, this is the vocabulary you'll want to use. So not only is it here to act as a prompt, but it will also help you with your spelling. So the key vocabulary for today is separate, mixture, solution, suspension, soluble, insoluble, dissolve, solid, liquid, filter, sieve, magnetic, and evaporate. Okay, let's make a start. So it's the very beginning of term. Getting up in the morning is still really tricky. So when I woke up this morning, I made 4 massive mistakes. Instead of pouring my cereal and my milk together and my tea and my milk and putting my sandwiches together, I accidentally made 4 completely strange mixtures. I made a water and sand mixture, flour and raisins mixture, a water and salt mixture, and a rice and paper clips mixture, because obviously I would have paper clips in the kitchen. So I've made 4 completely random mixtures and I need to separate them back out again because I need my paper clips separate from my rice. It's no good together. So in science we can classify, so we can name the different type of mixtures that we make, and it doesn't matter if we're combining solids or liquids or anything like that. We can classify what these mixtures are called. So I've given you down the side here some examples of how we might classify some of these mixtures. Now the first 2 are nice and easy. It's a mixture of 2 liquids or a mixture of 2 solids. Those are fairly simple. You can see then the third one is a solution. You can see that in bold. And a solution is when you've got a mixture of 1 liquid and 1 solid, where the solid has dissolved in the liquid. So the solid is soluble and the solid has dissolved into the liquid. That is called a solution. The fourth one is called a suspension. And that's when there's a mixture of a liquid and a solid, but this time the solid is insoluble and the solid particles will not dissolve in the liquid. So in a solution, the solid has dissolved into the liquid. You probably won't be able to see the solid anymore because it's dissolved into the liquid. And in a suspension, the solid doesn't dissolve into the liquid. I wonder if you could have a little look at those messed up my words then. Those 4 classifications and see if you can match them to my random mixtures. My water and my sand, my flour and my raisins, my water and my salt, and my flour and my paper clips. Flour is rice. Rice and paper clips. I'm not going to pause the recording, I'm just going to press on. Let's pause the video there and see if you can match them together. The best way to present this would be to write which mixture you're doing, for example, water and sand, and then maybe put a little dash and then tell me what classification it is. So for example, do you think water and sand is a mixture of 2 liquids? If you did, that's what you would write afterwards. Pause the video there and see if you can match together the classifications to the mixtures. Have you matched those together? Okay, let's have a little look at what the answers would be. So we can see here how I've matched the classifications to the different mixtures. So there were no mixtures that were just 2 liquids together. There were no mixtures that was a liquid and a liquid. There were, however, 2 mixtures of solids. Both the flour and the raisins are solid, and both the rice and the paper clips are solid. So both of those mixtures was just a mixture of solids together. So we would classify them as a mix of solids. A solution, there is an example of a solution where there's a liquid and a solid and the solid has dissolved, and that's the water and the salt. If I mixed accidentally or on purpose salt with water, then the salt would dissolve into the water. Now, it doesn't disappear, it would create a salty water. I wouldn't be able to see the salt particles anymore, but it would still be there, but it would have dissolved into the water. So that is a solution. The salty water would be a solution. There is also an example of suspension, because the water and the sand would be a suspension, because the sand isn't going to dissolve in the water. So when I look into it, I will be able to see the sand floating around in the water, and that's a suspension. So we have an example of a solution, a suspension, and a mixture of two solids. If that's what you put, well done. If that's not quite what you put, pause the video here and just correct what you had, just so that going forward you are 100% confident with what kind of mixtures or what kind of classifications. Now that we've classified what each of my mixtures are, we can start to decide how we would best separate those mixtures back into its original materials. So I wonder if you can have a think about how you might be able to separate these different materials, and will the same method work for each mixture? For example, how you separate the flour and the raisins, would that be different to how you would have to separate the water and the salt? And remember, we want a really effective separation method. So for example, the answer of can I just pick all the raisins out of the flour is not really a scientifically effective separation method. I'm sure it would work, but it's not very scientifically effective. So we want the best separation methods. You need to think about, are some mixtures easier to separate than others? And do any separations require a change of state? And remember, a change of state is when a solid changes into a liquid, or a liquid changes into a gas, or a gas back into a liquid, or a liquid back into a solid. So have a little think and pause the video here. Maybe make some notes about how you think we might separate the water and the sand suspension, or the water and the salt solution, or the flour and raisins mix of solids, or the rice and paper clips mix of solids. Have a think about the effective ways we might separate, and you might want to rewind back to the key vocabulary section, because there might be a few hints on that slide if you are stuck. Hopefully you have paused the video there and thought of some separation methods. I'm going to show you now some of the separation methods that I've come up with to help separate these mixtures back into their original materials. And here they are. So the first one is sieving, and that's the picture you can see on the top left. And sieving is when we use a surface or a bowl that has some holes in it, and we can use sieving to separate solids that have different particle sizes. For example, I might want to, in the kitchen, I might have a mixture of maybe sugar, and if I've been on one of my random mixing adventures, I might have peas in there, sugar and peas. That's a mixture of two solids. Now, the holes are big enough in the sieve to let the sugar through, but they're not big enough to let the peas through. And that way, sieving is a good way of sieving two solids apart and separating the larger particles of one solid from the smaller particles of another. We've also got filtering, which is the picture you can see in the top right. And filtering is a little bit different to sieving. Filtering is when you pass a liquid or a gas through a material to separate larger solid particles from that liquid and gas. Now the one you can see there is coffee, and we've got the coffee beans, and they're pouring the water in, and the filter paper is stopping the coffee particles from coming through, but it's allowing the coffee water to come through. So filtering is a really good one when we've got a mix of a solid and a liquid, where the solid particles are still present and we can separate them in that way. We've then got evaporating, which is the bottom left, and I'm sure you are familiar with evaporating. Evaporating is the change of state separation. When we have a certain type of energy, mainly heat energy, onto a liquid, Then the particles of that liquid will heat up and they will start getting lots of energy and start moving around, and they will turn into gas particles. Now, evaporating is really, really helpful if, again, you want to separate liquid particles from solid particles. And this is especially useful when the solid particles in the liquid aren't present or aren't visible. This is really helpful, for example, if you're in the wilderness. So we see a lot of this when we look at Bear Grylls, when we study natural disasters. If you've got dirty water, one way to filter the liquid from the dirt particles is by evaporating it and then catching the condensation, and it'll be clean water. The last one's a bit more of an out there one. It's magnetic pull. Now, hopefully, you will already have guessed which mixture of mine the magnetic pull will be effective for, but we know that certain materials have magnetic pull and magnetic force and will be able to be separated from those materials that do not have magnetic pull. Looking at those separation options and how I've just described them, can you see if you can match the separation type or the separation method to the mixtures that I've got, and see if you can match them most effectively, and one will match to each of my combinations. Let's see what you come up with. If you've not done already, make sure you've paused the video and tried to match the separation methods to my original mixtures. So hopefully your combinations look a little bit like this. The water and sand suspension, that would be best separated using filtering, because the water could easily pass through the material and get through to the side, but the sand particles wouldn't, and they would be separated. You might think, oh, well, maybe you can sieve water and sand, and you could if you had a very, very fine sieve, but actually you might find that a lot of the sand particles still get through the very, very small holes of the sieve, so actually the most effective would be to filter it. Flour and raisins, hopefully you said that you would need to sieve it, because the fine, small flour particles would be able to pass through the sieve's holes, but leave the raisins, which are a lot bigger and wouldn't fit through the hole. That would be the best way to separate the flour and raisins. For the water and the salt, hopefully you said evaporation, because the salt has dissolved into the water to make it a solution. And if we try to filter it or sieve it, then a lot of the salt particles would still get through. Whereas if we evaporate, the water would turn into a gas and would rise up, and we could catch it in a condensation fabric or a plastic bag or something like that. Now, salt particles, even if they're dissolved, don't have the ability to turn into gas particles. So that would be a really effective way of separating the water and the salt. And hopefully you had this one, the rice and the paper clips. Obviously, the paper clips are magnetic and they would be attracted to the magnet, but the rice would not. So hopefully those are the separation methods you identified for each classification of mixtures. So your independent task for each mixture, I would like you to identify what the mixture is. For example, you might have water and sand. Then the classification, so underneath water and sand you might have, well, that's a suspension, so you'd write suspension. Then the separation technique and why it's the most effective. So underneath you'll have water and sand, underneath that you'll have the suspension, and then underneath that you'll say the most effective separation technique would be the filtering, because, and then you'd explain why. If you're not sure why, go back to the last slide and have a listen again of why that was the most effective. And then finally, you're going to draw a diagram, and you're going to label those diagrams for me. And you're going to try and show me through scientific diagrams, the process of filtering or sieving or evaporating or magnetic force. If you're not sure, maybe you can go onto the internet and have a little bit of a research of those separation methods. And you're going to do that for each mixture. So you're going to end up with 4 pieces of information. You're going to have each mixture, each classification, each separation technique, and a diagram. Now, how you present this, you might do it on a poster, you might do it on your A4 piece of paper, you might just do it in different boxes, you might even decide to put it on a PowerPoint. However you want to do this, it'll be great. Once you've done that, It says stick in the plenary questions because I use this in class, but I just want you to look at the next slide, which is the plenary questions, and see if you can answer any of them. And here are your final plenary questions. These are just a few questions you can try and answer at the end of the lesson to see if you can use your knowledge in different contexts. If you're uncertain of any of the answers, maybe go back to some of the other slides and listen to the explanations again and see if you can figure them out. With all your work today, it would be great if you could send it in so I can have a little look at it. rsa.year6@3-saints.org.uk. And remember, you can present this in any way that you want, whatever you're able to do at home. I hope to see you guys really, really soon, and I will put up another science lesson next week. Bye.